Thanks so much for the opportunity to be here today. I'm going to be sharing my vision for OceanCloud, a way we can transform oceanography with a new approach to data and computing. Let me quickly introduce myself. My name is Ryan Abernathy. I'm a physical oceanographer at Columbia University and Lamont Doherty Earth Observatory. I work with high-resolution satellite data and ocean simulations. This work with big data sets led me towards software development and infrastructure. I'm a co-founder of the Pangeo project, an active open source developer, and an advocate for open science. In this talk, I'm going to describe a problem, which is that the ocean data sets we have are huge and complex, and this is limiting scientific inquiry and restricting participation in oceanography. The solution I'll propose is OceanCloud, which is a new approach to infrastructure based on cloud computing, open data, and open source software. Here's a wonderful animation from NASA that shows the beauty and complexity of the Earth system. We're looking at a lot of different fields observed by satellite and simulated by computer that show the interplay of different parts of the Earth system. And of course, the ocean is a key one of these. So the graph I'm showing here shows the expected growth of NASA's satellite data archives over the coming decade. And what we see is that they're measuring the data volume in hundreds of petabytes. It's not just satellites and computer models that are generating a lot of data. We also have fantastic new observations from autonomous observing systems like Argo. Buried in this complex data set are hundreds of exciting scientific discoveries waiting to happen. But I'd argue that a lot of our data are going underutilized because we don't have the right infrastructure to support truly interactive exploration and analysis of these data. The standard approach we have in oceanography is to download data to local computers. But of course, you're not going to be able to download a petabyte of data to your laptop. So we need a different approach. What do we tend to do today? What's the status quo for our ocean data infrastructure? Well, I'd like to argue that privileged institutions create so-called data fortresses. Let me explain what I mean by that. So here's my university, Columbia, and we want to support the researchers at our institution to work with ocean data. We bring data in, we download it, and we store it locally on our servers and hard drives. And maybe we put a supercomputer in the basement that allows us to process it more quickly. And this works okay, this works for us, but there are a lot of downsides to this way of doing business. The key one is that our results are not reproducible outside of our fortress, and we don't like to let other people into our fortress. This creates a huge barrier to collaboration. It's also inefficient and duplicative since most institutions are creating their own fortress and doing many of the same activities to make ocean data accessible. This can't really scale to these future data needs because not every institution can be storing petabytes and petabytes of ocean data. And finally, this really limits inclusion and knowledge transfer because it restricts who can participate. If you don't happen to be at a privileged university like Ivy League Columbia, you may not have access to a data fortress at all, and you're just not able to do this type of science. So what's the alternative to building data fortresses? So solving the challenges of working with big data sets is one of the core goals of our Pangeo project. Pangeo is really a grassroots collaboration between scientists and software developers around open source tools for solving real-world science problems. Our project received foundational support from the NSF EarthCube project, and now it has a wide range of international partners and industry connections. The Pangeo process is centered around open development. At the core are scientific use cases. We ask, what are the bottlenecks to scientific progress, and where can we target development of tools and infrastructure to help open those bottlenecks? That means we contribute very widely to the open source software ecosystem, and we work on solving integration challenges between data and software. And then we deploy analysis environments on a wide range of different computing resources, such as cloud and high-performance computing centers. And this work has really led us to a certain pattern that we think works very well for data-intensive computing. So I'd like to describe briefly the three pillars of cloud data environments. A key part of this is analysis-ready data. What we want to do is provide to scientists cleaned, curated open access datasets that are available via high performance, globally available storage systems. That means that scientists don't have to spend their time downloading and cleaning data, but they can go straight to processing data. Another key part of this is the concept of data proximate computing. Rather than downloading data to their computer, scientists bring their analysis to wherever the data lives. And that's possible thanks to great technologies like Jupyter that allow you to do rich interactive scientific analysis just through the web browser. And then the final element is elastic scaling. This is a technical term that refers to the ability to automatically provision many computers on demand to accelerate big data processing. And this is what allows us to work with those petabytes of data. These three pillars of analysis-ready data, data proximate computing, and elastic scaling can really be implemented on any major cloud provider. But the big advantage of using the cloud is that we can accommodate any amount of data and any number of users. And that's something that our current approach to infrastructure just can't do. So OceanCloud is really just this vision for data proximate cloud-based computing applied to the field of oceanography. If we can bring these technologies to bear on oceanography, instead of many data fortresses, we'll have a single data watering hole for oceanography. What I mean by that is if we can bring data from many different providers into a common environment where it's directly accessible to on-demand scalable computing, this is going to be a place where all kinds of different scientists, educators, and industry users come together to analyze data. That's going to create new collaborations among research teams, new opportunities for education and outreach, and new partnerships with industry. So compared to the old way of doing business inside our data fortresses, this OceanCloud-based data watering hole will enable faster science, more discoveries. It's inherently reproducible to work this way because everyone has access to the same data and same computing environment. It will permit seamless global collaboration and unlock new collaborative potential. It will unleash the creativity of our scientists who are currently stuck with a lot of tedious data management work. It'll be cost effective. It'll help us connect with industry partners who naturally tend to do their business in the cloud. And most importantly, it will be accessible to all. It will allow people who are not at these very privileged, rich institutions to participate in data-intensive oceanography. So I hope you agree this vision of a new approach to ocean data infrastructure sounds really exciting. Now, how can we achieve it? Well, I think the time is ripe because many agencies like NASA and NOAA are already moving their data distribution to the cloud. But the missing link right now is providing accessible cloud computing environments to all oceanographers. This is a place where Pangeo and the partners we've developed can help. We have to avoid building new fortresses in the cloud and instead ensure operability from the start. That means working together across agencies and across disciplines. One idea is that a National Oceanographic Partnership Program, NOPP, could provide funding, help facilitate interagency collaboration, and support user adoption to help realize this vision. I'm deeply grateful for the opportunity to share these ideas. If you'd like to learn more about our Pangeo project, here are some links you can follow.